Okay, so I've come back now and I've found the problem, which is that with this particular example, even though this formula is valid, it may be easier to keep working in terms of x, in which case our radius, so the how far away we are from the axis of rotation is going to be x, and we multiply by 1 plus f prime of x squared, all under the square root with respect to x. So this sounds counterintuitive. It doesn't sound like it would give us the right version, but keep in mind that this is still ds. So ds can be expressed simultaneously in x or in y. The main difference here is that instead of expressing things in y, we express things in x. And notice that these two things are still equal to each other if we're expressing x as a function of y. But here we're just going to leave it as x, and we're going to leave everything in terms of x. So here's why that's simpler. So if we take our f of x equals 1/3 x to the 3 halves, then f prime of x is 1/3 times 3 halves times x to the 1/2, which simplifies to 1/2 x to the 1/2. Okay, putting that into our new, which is equivalent, let me be clear, it's equivalent to these two formulas will work in the exact same situation when we're rotating about the y-axis. Just sometimes one is more advantageous than the other, and this is one case where using version 2 is more advantageous, because if we then express the surface area integral in terms of x, get the integral from 0 to 12 of 2 pi x times the square root of 1 plus 1/2 x to the 1/2 squared dx. And now you'll notice we actually get a quite simple expression inside the square root. And if we pull out a 1/4 to get 2 pi x times 1/2, we can simplify this even further into this square root expression. No need to fumble with the limits of integration, none of that. And in front of the square root expression, we have an x, not an f of x, or a g of y, just x. And so, if we write this as pi times the integral from 0 to 12 of x squared of 4 plus x dx, we can now institute a pretty simple substitution of u equals 4 plus x, which of course also yields x equals u minus 4, and du is dx, because u is a linear function of x. Now, replacing the limits of integration, u of 0 becomes 4. U of 12 becomes 16. And we transform this integral into pi times the integral from 4 to 16 of u minus 4 times u to the 1/2 power, du. And now we can distribute that u to the 1/2, and we have a integral in which we can apply the power rule. So we get equals pi times the integral from 4 to 16 of u to the 1 time plus 1/2 3/2 minus 4 times u to the 1/2 du. And so this will yield pi times, and we're going to apply FTC2, 2/5 u to the 3/2 minus 4 times 2 over 3 of u to the 3/2 power. What did I put 3/2 power in here? Sorry, that should be u to the 5/2 power, okay? And evaluate that from 4 to 16 and 4. And I'm not going to get into those details. I just wanted to deliver the actual integral as it should be carried out for this example. So you can go ahead and ignore what happened in the last video.